All right, so this is a key to the test three. And um, so in number one, you want to subtract these two polynomials. And remember, when subtracting polynomials, it's always a good idea to change the subtraction to addition problem. So we're always going to add the opposite. So this becomes 3x to the 6th minus 5x to the 4th plus 6x cubed minus 3x plus 4, and they're going to add the opposite. So the opposite of 2x to the 6th is a negative 2x to the 6th. The opposite of a positive 8x to the 4th is a negative 8x to the 4th. The opposite of a negative x cubed is a positive x cubed. The opposite of a positive 7x is a negative 7x. And the opposite of negative 1 is a positive 1. And now we're adding two polynomials. And so to add two polynomials, you're just basically combining like terms. So notice I have a 3x to the 6th and a negative 2x to the 6th. So remember, in combining like terms, you're basically adding those coefficients. A positive 3 and a negative 2 is a positive 1. So it becomes 1x to the 6th, which is just x to the 6th. Now let's go to the next term, negative 5x to the 4th. So negative 5x to the 4th, I can combine with a negative 8x to the 4th. A negative 5 and a negative 8 is a negative 13. So you get negative 13 x to the 4th. Then we have 6x cubed that are combining with 1x cubed. So 6 plus 1 is 7. So I get 7x cubed. And then we have our linear terms. So negative 3x and a negative 7x is a negative 10x. And then your constant, a positive 4 and a positive 1 is a positive 5. All right, so that was number one. Number two, you want to simplify this expression. Now, when simplifying expressions, you need to make sure that you factor completely. So we have, let me go ahead and rewrite this over real quick. We have x squared plus 2x minus 3 divided by x squared plus 7x plus 12. All right, so you want to factor both the numerator and the denominator. So we have these polynomials that we need to factor, and they are factorable. And so when I factor the numerator, I'm going to get x plus 3 times x minus 1. And when I factor the denominator, I'm going to get x plus 3 times x plus 4. And then next step is to reduce your common factor. So these two factors are in common. So I can divide those. So I get 1's in that place. So 1 times x minus 1 is x minus 1. And then 1 times x plus 4 is x plus 4. And there's your answer. Okay, so that's number two. Number three, again, you want to simplify this expression. Now notice that the numerator is a difference of two squares. Let me go ahead and rewrite this so you can see it better. So that's a difference of two squares, the numerator. And so that becomes 3 minus x times 3 plus x divided by, and then the denominator, I can factor that as x minus 6 times x minus 3. All right, now notice that you don't see any of those factors being exactly the same, but I want you to remember that the factor 3 minus x and the factor x minus 3 are opposites. So see 3, negative x, positive x, those are opposites. So you got to think of opposites. And when two factors are opposites and you're dividing them, then one factor is a 1 and the other factor is a negative 1. So always make the factor in the numerator negative 1 and the factor in the denominator a positive 1. So there are multiple ways of writing your answer now. So you could say negative in parentheses 3 plus x, just like that, divided by x minus 6. There's one answer. Or if you want to distribute, you can. That's nothing wrong with that. So negative 1 times 3 is a negative 3. Negative 1 times x is a negative x. Divide x minus 6. There's another answer. Or if you want to, you can take this negative out here and put out in front of the fraction, meaning it looks like this. 3 plus x divided by x minus 6. Okay, where you have the negative out in front. I mean, I put it way out in front. I should not have. It should be a little bit closer. And if you want to put the x first, you can. So in other words, you could say negative x plus 3, 3, divided by x minus 6, just like that. So there are multiple ways of writing the answer. Okay, number 4, all they want you to do number 4 was to find the least common denominator of those two rational expressions. So the first thing you had to do was to factor that denominator. So notice that x squared plus 10x plus 25 is a perfect square trinomial, meaning that I can factor this as x plus 5 squared. And then in the second one, I can first of all factor out an x to get x times x plus 5. So remember, the least common denominator must include every factor that you see in your denominators. So I see a factor of x plus 5, there are 2 of them, and I see a factor of x plus 5, and there's 1 here. So you must use the one with the greatest exponent. So I'm going to need x plus 5 to the second power. The other factor I see is an x, so I got to have an x as well. So now there's your least common denominator, x times x plus 5 squared. Number 5, so you want to multiply this binomial. So remember, 5x squared, 5x minus 2 squared means 5x minus 2 times itself. And so I'm going to go ahead and FOIL this. 5x times 5x is 25x squared. The outer, 5x times a negative 2 is a negative 10x. The inner, negative 2 times 5x is a negative 10x. And the last, a negative 2 times a negative 2 is a positive 4. Combining like terms, I get 25x squared. A negative 10x and a negative 10x is a negative 20x, and then plus 4. And so that's the answer number 5. Okay, number 6, you have to recognize that number 6, that's the difference of two squares. And so I can factor this as 2x minus 3 times 2x plus 3. So that was an easy one. That's a quick one. Number 7, you want to factor this trinomial. Notice that, remember, I always look for GCF if it's other than 1. So the GCF here is 1 in all 3 terms. So I'm going to go directly to the 2 binomials. And for 6x squared, let's try 3x and 2x. And 15, let's try 5 and 3. Now remember, I'm using 5 and 3, right, for 15. So I cannot put the 3 here. In one of our lessons, we know that if we put the 3 here, that means I can factor out a 3, which means that all these terms are divisible by 3, and they're not. This is a 1 here. So I need to put the 3 here and the 5 here. The last sign is negative. That means these signs in here are different. And I need the middle sign to be positive. So in order for that to work, this would have to be positive. This would have to be negative. And you can always check. 3x times 2x, 6x squared. The outer is a negative 9x. The inner is a positive 10x. 10x and negative 9 is a positive 1x. And then 5 times negative 3 is a negative 15. So there's the answer to that one. Okay, now number 8, you want to solve the following equation by factoring. So make sure you always follow directions. Direction says factoring. So it's already in standard form, meaning that you have all the terms to one side, it's in descending order, and you have 0 on the other side. And so let's go ahead and factor this. And so in fact, you get x minus 5, x plus 2 equals 0. So that's one of the steps you had to show. The next step you had to show was the fact that you are using the zero factor property. Remember, the zero factor property says when you have 2 or more factors whose product is 0, then one of those has to equal 0. So then you're going to say x minus 5 equals 0 or x plus 2 equals 0, and then solve each of those linear equations. So x equal 5 and x equal negative 2. So again, there's your work. And there's your solution. There's your answer. All right, number 8. So that was number 8. Now, number 9 is also a problem where you had to solve this quadratic equation by factoring. But notice this one is not in standard form. So let's go ahead and put it in standard form. And I'm going to go ahead and write in descending order. So I'm going to bring the negative 10x over. So it'll become a positive 10x. And then minus 3 equal 0. Okay, now factoring. The GCF is 1, so I'm going to go ahead and factor as 2 binomials. Don't forget that's equals 0. So let's use 4x and 2x. And for negative 3, I'm going to use 3 and 1. So let's go ahead and put the 3 here, the 1 there. The last sign's negative, so those signs are different. And I need the middle sign here, the middle term, to be a 10x. In order for that to be a 10x, then that means that the 3 would have to be positive and the 1 would have to be negative. And you can verify as well If you FOIL this out, you're going to get 8x squared plus 10x minus 3. Now, using the zero factor property, so I have two factors whose product is 0. So one of those has to be 0. So set each one of those equal to 0. And then solve for x. I get 4x equal 1. And then divide both sides by 4. At x to be 1/4. Over here, subtract 3 from both sides. I get 2x equals negative 3. Divide both sides by 2. I get x to be negative 3/2. So those are your solutions. So this is your work, and that's your answer. All right, in number 10, you wanted to multiply these two rational expressions. So remember, in multiplying rational expressions, the first thing you have to do is factor. So let's go ahead and factor each of the numerators and each of the denominators. So in the first numerator, I can factor that as x minus 3 times x minus 2. The denominator is a difference of 2 squares. So I can factor as x minus 3 times x plus 3 times the numerator here. I can factor out an x, so that's x times x plus 3. The denominator I can factor as x plus 4, x minus 2. All right, so I factored all numerators and all denominators. The next step is to reduce your common factors. So notice I have an x minus 3 here, I have a factor down here. So those divide out. Remember, factors of 1s in their place. I have an x minus 2 here, I have 1 in the denominator, those divide out. I have an x as a factor, I don't have an x as a factor down there, so that stays. I have an x plus 3 here, and I have 1 here. So the only thing that's left now is 1 times 1 times x times 1, which is x, divided by 1 times 1 times x plus 4 times 1, which is x plus 4. And so that's number 10. Okay, number 11. You are now dividing rational expressions. So let's go ahead first of all and change this division to multiplication. So whenever you change a division to multiplication, you multiply by the reciprocal of the rational expression following the division symbol. So it becomes x squared minus 25 divided by x squared minus 16 times, and then the reciprocal would be x plus 4 divided by x plus 5. Now that brings us to the previous problem now, number 10. So now we're going to factor all numerators and denominators. So I get x minus 5 times x plus 5, difference of 2 squares. This is also the difference of 2 squares, x minus 4, x plus 4, times, I cannot factor these, so that's going to stay x plus 4, and that's going to stay x plus 5. All right, so let's go ahead and reduce. So x minus 5 here, I don't see any down there. X plus 5, there's 1 here, so those divide out. X plus 4 divides with this one. Don't forget to put 1s in their place. And so notice I get x minus 5 times 1, which is x minus 5. X minus 4 times 1 is x minus 4. And there's the answer. All right, number 12, you want to simplify this expression. And remember, you want to make sure that your final answer has positive exponents only. So let me go ahead and rewrite this over so it'll look a little bit better. So we get 25x cubed times x to the 5th raised to the 4th divided by 5x to the 10th. That's a 10 right here. All right, so first thing we need to do is recognize that I can simplify x to the 5th raised to the 4th. So when you have a power, it's a power, you multiply those exponents. So this becomes 25x cubed times x to the 20th power. 5 times 4 is 20. Divided by 5x to the 10th. What I would do next is go ahead and simplify this numerator. When you multiply like bases, you add exponents. So x cubed times x squared, x to the 20th rather, is 20 plus 3. So it'll be x to the 23rd. So it becomes 25 x to the 23rd divided by 5 x to the 10th. Now what I would do next is I would rewrite this fraction right here as a product like this. 25 divided by 5 times x to the 23rd divided by x to the 10th. And then simplifying, 25 divided by 5 is 5. And then when we divide like bases, we subtract exponents. So that's that quotient rule for exponents. So it'll be x to the 23rd minus 10. But 23 minus 10 is 13. So that's 5x to the 13th power. And that's it. We're done. There's nothing else to do because my exponents are now positive. All right, so that's number 12. Number 13, we have, this time we have negative exponents, but let me go ahead and rewrite it over. I have 17x to the negative fourth times x to the sixth raised to the negative, I think that's a 3, negative 3, divided by 9 times x squared raised to the negative fifth power. All right, so first of all, let's go ahead and get rid of those parentheses here in both cases. When you have a power raised to power, you multiply those. So you're going to get 17x to the negative fourth times x to the, and then 6 times negative 3 is a negative 18. Divided by, and then 2 times negative 5 is negative 10. So 9x to the negative 10. Just like we did before in the previous problem, you multiply like bases, you add exponents. So this becomes 17 x to the negative 4 minus a negative 18, right? I'm sorry, plus, excuse me. You add exponents, plus a negative 18, divided by 9x to the negative 10. All right, so negative 4 and a negative 18 is a negative 22, right? So that's 17x to the negative 22nd power, divided by 9x to the negative 10. All right, now, the next step is this. Just like we did in the previous problem, I'm going to rewrite this as product of two fractions. So it'll be 17 ninths times x to the negative 22nd divided by x to the negative 10. Now I cannot reduce this, so that's going to stay the same. So that's going to stay 17 ninths times. All right, now remember, when you multiply like bases, you subtract exponents. So it'll be x to the negative 22nd, subtract a negative 10. But remember, subtracting a negative 10 means the same thing as adding the opposite. So that becomes 17 ninths times x to the negative 22nd plus 10. Negative 22 plus 10 is a negative 12, so that's 17 ninths times x to the negative 12. All right, so now I have a negative exponent. But remember, x to the negative 12 is also the same thing as saying 1 over x to the 12. And then you're going to write this now as one fraction. Don't leave it as two fractions like this. Write it as one fraction. So you can get 17 times 1 is 17, and then 9 times x to the 12. And so that's your answer, one fraction. Okay, number 14, you want to find the degree of each of those polynomials. So remember, when you have multiple variables in a term, to find the degree of a term, you're basically going to add the exponents of each variable. So this is 3, this is 4, so you're going to get 7. So the degree of this monomial is 7. Now, here you have a polynomial made up of 3 terms. So the degree of this polynomial will be the number that is the largest of each of those degrees. So basically meaning you find the degree of each of those terms. So the degree of this term here, 2 plus 5 is 7. The degree of this term here, 3 plus 1. If there's no number there, remember that's understood to be 1, is 4. And the degree here, 6 plus 5, is going to be 11. So the degree of this polynomial is the one that's the largest exponent. So the answer is 11. Okay? All right, that was 14. All right, 15, you wanted to add those two rational expressions. So let's first of all find the least common denominator. And in this case, remember, finding the least common denominator, you have to factor your denominators. Each of those are linear factors, so there's not much you can do in terms of factoring, right? They cannot be factored. So your least common denominator is a product of each of those factors that you see. So I see an x plus 3, and I see an x minus 1. So there's your least common denominator. It's a product. Now what you're going to do now is you're going to write two fractions with that denominator. X plus 3, x minus 1. X plus 3, x minus 1. And then you're going to write equivalent fractions. So notice I want to go from here to here. I want to go from this denominator to this denominator. So what's missing is that x minus 1. So that means I got to take this 3 and I got to multiply by x minus 1. And always verify. See, if you look at the x minus 1s that are in common, you kind of cover it up. What you see here is what you had, right? Same thing here. So this is an x minus 1. I have the x minus 1, but I'm missing the x plus 3, right? So you can say 2 times x plus 3. So again, cover up what they have in common, and notice what you have left is what you started out with. Okay, now the next thing to do is, now since these two fractions have that same denominator, you're going to write them both as one fraction. So x plus 3 times x minus 1. And then the numerator, let's go ahead and distribute. You get 3x minus 3, 3x minus 3, plus, and then the same thing here, 2x plus 6. And then combining like terms, 3x and 2x is 5x, a negative 3 and a positive 6 is a positive 3, all divided by, and then leave the denominator factored. Don't multiply it out. So leave it as x plus 3 times x minus 1. Now, you cannot factor the numerator, but if you could, go ahead and do that. And if there are any common factors, you reduce. So in terms of simplifying, I could not simplify this. So there's your answer. Number 16 was easy because I already factored the denominator for you. So we have 2 divided by x minus 3 times x plus 2 minus 5 divided by x plus 2. So your least common denominator would be x minus 3 times x plus 2. And the next one is x plus 2, but I have it listed. So your least common denominator is x minus 3 times x plus 2. So now we're going to write two fractions with that denominator. So I'm going to say x minus 3, x plus 2, minus x minus 3, x plus 2. So just like that previous problem that we did, we're asking ourselves, I have this, I want this. But notice that these factors are exactly the same, right? So that means that this fraction is equivalent to itself. Over here, though, I'm missing something. I have the x plus 2, but I'm missing the x minus 3. So in order to write equivalent fractions, I've got to multiply the 5 by x minus 3. All right, now be careful with the next step. So I want you to remember that subtracting means the same thing as adding the opposite. So if you need to, then here's what I would do. So first of all, notice that those two fractions have that same denominator. So I'm going to write them as one fraction now. X minus 3, x plus 2. And so I'm going to get 2 plus the opposite of 5, which is a negative 5, times x minus 3. And then distribute the negative 5. I get 2. Negative 5 times x is a negative 5x, right? Negative 5 times a negative 3 is a positive 15, all divided by x minus 3, x plus 2. Leave the denominator factored. Don't multiply this out. And then combining like terms, I get negative 5x, 2 and 15 is 17, divided by x minus 3, x plus 2. Now, there's no way I can factor the numerator, but if you could, you need to, because you need to see if you can reduce any factors. In this case, I cannot, so there's the answer. All right, so I believe that is the key to test number 3.